Good morning. This is Dr. S. Subbulakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. And I am here to promote lecture video on the course Probability and Statistics. And now we are on to the topic Statistics. Today we are going to discuss the topic related to chi-square test. And in testing of hypothesis, we have chi-square test as a test for small samples. Here we have some of the applications of chi-square test, to which we have a student to explain the applications of chi-square test.
Here are the applications of chi-square test. Chi-square test is used to find the relationship between two attributes and also fairness, nothingness of two things. And in real life, in genetics, in quality control, in cryptography, it is applied.
So, a student has given some of the applications of chi-square test, and now we are going to see a problem related to chi-square test. So, here is the problem. We are given here the days count and the number of accidents happened. So, we are given that the number of accidents happened in a data in a week time. So, in day 1 we have 14 number of accidents, in day 2 we have 18 number of accidents, in day 3 we have 12 number of accidents, in day 4 11, in day 5 15 and day 6 14. So, here this is the data given for us. With this data, what we are going to test is, we are going to test the number of accidents occur uniformly over the week. So this is the particular word which we identify it as we should use only the chi-square test. So uniformly distributed means it indicates that we have to use chi-square test for this particular problem. So we are given with the data for the number of aircraft accidents happened in the week, and with that data we are going to test the accidents happened uniformly over the week. To start with the solution of our problem, we are in need of the formula to find the calculated value of chi-square. So here, chi-square calculated value can be found using this particular formula, which is summation of the observed frequency minus the expected frequency, the power square divided by the expected frequency. We have to take up the summation of the observed frequency minus expected frequency the whole square divided by the expected frequency. So this is what the formula is, and we are going to perform the calculations for this particular formula. Moving on to the solution, first we have to write what are we given with. What are we given with? We are given with the number of accidents here. So we are about to find the total number of accidents. The total number of accidents is, we are just going to take the count of all the 6 here. We are just going to sum up all the 6. Therefore it is 84. And how many number of days this has happened? It has happened for 6 number of days. So this is what we have written here. We have written here the total number of accidents, which is 84, and the number of days is 6. Now we are about to calculate the expected frequency, which is our E, represented here in the formula. So expected frequency E is equal to the total number of accidents happened divided by the number of days given. So this is how we calculate the expected frequency of the given problem. So here our expected frequency is E is equal to 84 by 16, which is equal to 14. We have got the value of E to be 14 for all the observed frequencies given here. Next is, actually we are moving on to the testing here. The first step is framing the null hypothesis. What is our null hypothesis? What we are asked in the question will be the null hypothesis. So it is represented by H0. What we are asked in the question, the accidents occur uniformly over the week. So occurrence of the accidents uniformly over the week is your null hypothesis. And second step is framing the alternative hypothesis. So this is what our alternative hypothesis is. We are representing it by H1, that does not occur uniformly over the week. This is our alternative hypothesis, which is complementary to the null hypothesis. Null hypothesis is represented by H0 and alternative hypothesis is represented by H1. What we are asked to test is to be in the null hypothesis and its complement to be in the alternative hypothesis. The next step is framing up or finding out the level of significance. The significance level is fixed for each question. So since we are not given with any of the significance level here, we are just about to fix it as 5%, which is 0.05 for this particular problem. So now we have got 3 steps in this particular problem. We have got the expected frequency value, which is to be 14. Null hypothesis we have framed it, alternative hypothesis and the level of significance also we have fixed it. Now we are about to construct a table for this particular problem. We have framed all the three steps here, and with this in hand, we are going to find the chi-square calculated value. So in the first column, we have the observed frequencies, which is given in the table. Here. We have just replaced it, and the expected frequency as we have calculated in the step number 1, which is 14 for all of the observed frequencies. And on subtracting it from the observed frequency and squaring it up, we have these such values. And on dividing it again by the expected frequency, you will have these values here. On a simple or minor calculations, we will have these set of values here. Now what we have to do, we have to take the summation values of all those things here on the table, column number 4. On our computing it, we will have 2.143 as the value of chi-square value. That is nothing but the summation of observed frequency minus expected frequency the whole square divided by the expected frequency, which is found to be 2.143. This is our calculated value for the data given. So what we have to do next, we have to find the degrees of freedom for the particular value here. Degrees of freedom is represented by rho, which is equal to n minus 1. N here is number 6. 6 minus 1, which is 5. So the degrees of freedom is fixed to be 5. Now we have to take the table value. What is the table value? Which is the standard value given in the table format for chi-square test. So chi-square table value, which is the tabulated value at 5% level of significance, as we have mentioned here, 5% level of significance and 5 degrees of freedom. We will have the tabulated value as per the table. The standard values we have 11.07 as the value here. So what we can do with the table value? We will just have to compare the chi-square calculated value with the chi-square tabulated value. So what is the comparison here? This is much lesser than the calculated value, which we can say it as the chi-square calculated value is lesser than the chi-square tabulated value. So what we can infer from this is, the result is, we can accept the null hypothesis, which is H naught. So if the calculated value is less than the tabulated value, what we can do, we can just accept the null hypothesis. Now coming to our null hypothesis, what is our null hypothesis? The accidents are distributed uniformly over the week is our null hypothesis. Therefore, our final result is the accidents are distributed uniformly over the week is our conclusion. So this is our, with the given raw data, we can find or we can test the given testing of hypothesis using the data given and using this type of chi-square test. So here are the one of such applications for chi-square test, and we will have some more problems in the same topic and in the few corresponding topics of the small samples.